Emotions. You feel them every day. Fear before a hard conversation, joy when something finally goes right, anger that rises before you even know why, grief that shows up months later, out of nowhere in the middle of a grocery store. You experience them constantly, but almost nobody knows what they actually are. Emotions aren't feelings, they're chemistry, electrical signals, survival instructions your brain sends to your body before your conscious mind has even caught up. By the time you think, I'm scared, your heart is already pounding, your muscles are already tensed. Your body acted first. Your awareness arrived late. Here's what's actually happening. Fear. Fear is your brain's oldest system. Deep inside your skull sits a small almond-shaped structure called the amygdala. Its only job is to scan everything around you for danger, constantly, even while you sleep. The moment it detects a threat, real or imagined, it fires, instantly, before the thinking part of your brain has processed a single detail. Adrenaline floods your bloodstream, your heart rate doubles, your pupils dilate to let in more light. Blood rushes away from your organs and into your muscles, preparing you to run or fight. This happens in milliseconds, faster than thought. The problem is, the amygdala can't tell the difference between a lion and a phone notification. Both trigger the same cascade. That's why public speaking terrifies people who have survived actual disasters. Your body doesn't grade threats, it just responds to them. Fear also has a memory problem. Once it learns something is dangerous, it generalizes. One bad dog becomes all dogs. One humiliating moment becomes all public situations. The brain would rather be wrong 1,000 times than miss a real threat once. It overcorrects by design, and that overcorrection follows you for years. Fear kept your ancestors alive. In the modern world, it mostly just keeps you awake at 3 a.m. Anger. Anger is fear with somewhere to direct itself. When your brain perceives a threat to your safety, status, or sense of fairness, the amygdala fires again. But this time, instead of retreat, it signals attack. Cortisol and adrenaline surge together. Your jaw tightens, your chest contracts, your hands may curl without you deciding to curl them. Anger feels like power, but it's actually your nervous system in emergency mode, trying to eliminate a threat as fast as possible. The prefrontal cortex, your rational brain, gets partially overridden. That's why you say things in anger you'd never say calmly. The part of you that calculates consequences has been temporarily demoted. Anger also has a physical come down. After the surge fades, cortisol lingers in the bloodstream for hours. That residual tension is why arguments at night ruin sleep, why you're still replaying the conversation the next morning. The chemicals don't care that the moment is over. Here's what most people don't know. Anger almost always has a softer emotion underneath it: hurt, fear, shame, embarrassment. Anger rises faster because it feels safer than vulnerability. It's the brain's armor, strong on the outside, protecting something much more fragile beneath. Joy. Joy is your brain rewarding you for doing something it wants you to do again. When something good happens, connection, success, pleasure, surprise, your brain releases dopamine, the chemical of anticipation and reward, then serotonin, which creates a quieter, deeper sense of well-being, then sometimes oxytocin, if another person is involved, pulling you toward them, creating the feeling of belonging. Joy doesn't feel the same every time. The spike of excitement when something unexpected goes right is dopamine. The warm, settled contentment of a quiet evening with people you love is serotonin. They use the same word for both, but they're chemically different experiences. Dopamine is also forward-looking. It fires not just when you get something good, but when you anticipate getting something good. That's why wanting something often feels better than having it. The brain rewards the chase more reliably than the arrival. The darker truth about joy is that the brain adapts. Whatever makes you happy now will make you less happy over time as your baseline shifts upward. That's why more doesn't fix anything for long. The brain doesn't feel happiness, it feels change. Sadness. Sadness is your brain slowing down to process something it can't immediately solve. When something is lost, a person, a version of your future, a belief you held about yourself, your brain enters a low energy state. Serotonin drops. Dopamine pulls back. Your body moves slower. Your thoughts turn inward. Appetite shifts. Sleep changes. This isn't malfunction, it's processing. Sadness carves out space for the brain to recalibrate, to update its model of the world now that something that existed no longer does. It's metabolically expensive and it's supposed to be. It signals to others that you need support. It forces stillness when stillness is what healing requires. Sadness also sharpens attention. Research shows that people in sad states notice more detail, make fewer errors in judgment, and remember events more accurately. The brain in a sad state is paying close attention to what went wrong so it doesn't happen again. It's not weakness. It's a very expensive form of learning. The problem is when sadness gets stuck, when the brain can't complete the process, that's when it tips into something else entirely: grief. Grief is what happens when loss is too large for sadness alone to hold. It doesn't move in a straight line. It doesn't follow stages on a schedule. It ambushes you. It retreats. It comes back without warning 6 months later when a song plays in a coffee shop and suddenly you can't breathe. Neurologically, grief activates the same brain regions as physical pain. It's not metaphorical. Losing someone important genuinely hurts the way a broken bone hurts, processed through the same neural pathways. Your brain built a map of the world that included that person. Now the map is wrong. Every moment that doesn't match the old reality is a small collision your nervous system has to absorb. Grief also disrupts the brain's prediction system on a massive scale. You reach for your phone to call someone and remember midway through that they're gone. Your brain predicted their existence and the world didn't deliver. That gap between expectation and reality is where grief lives, and it keeps reopening every time the prediction fires. Grief takes so long because the brain has to literally rebuild its internal model, memory by memory, expectation by expectation. It's not weakness. It's one of the most neurologically demanding things a human being can do. Disgust. Disgust evolved to keep you alive by stopping you from consuming things that could kill you: rotten food, contaminated water, biological waste. Your brain learned to attach a violent rejection response to specific stimuli so you'd recoil before thinking. The problem is disgust migrated. It didn't stay in the stomach. It moved into morality, into politics, into judgments about other people. The same neurological system that rejects rotten meat now rejects ideas, behaviors, and people that feel wrong in some hard to articulate way. Disgust is one of the most socially destructive emotions precisely because it feels like reason, but it isn't. It's a gut reflex wearing the costume of a moral conclusion: surprise. Surprise is the brain catching itself wrong. When reality doesn't match prediction, the brain fires a brief interrupt signal. Everything pauses for a fraction of a second while the system updates. That pause is surprise. It's neutral by itself. It becomes positive or negative depending on what the mismatch was. Surprise is also why novelty feels good. A brain that predicted correctly feels nothing. A brain that got surprised and updated successfully gets a small dopamine reward for learning something new. That's why travel, new experiences, and unexpected conversations can lift your mood without you understanding why. Your brain is being rewarded for updating itself. Embarrassment and shame. These two feel similar but operate very differently. Embarrassment is social. It's the flash of heat when you trip in public, say the wrong name, or send a message to the wrong person. It's brief, surface level, and almost always fades quickly because it's tied to a specific moment rather than a belief about yourself. Shame goes deeper. Shame isn't "I did something wrong." Shame is "I am something wrong." It activates the brain's social rejection circuitry, the same system that fires when you're physically excluded from a group. Because for your ancestors, being cast out of the tribe meant death, shame still carries that ancient weight. It makes you want to hide, shrink, disappear. Not because the situation requires it, because your nervous system is treating social judgment like a survival threat. Your emotions aren't weaknesses. They aren't overreactions. They aren't things to be ashamed of or pushed down or performed for other people. They are ancient, precise biological instructions, running perfectly on hardware built for a world that no longer exists, in a life that your brain is still catching up to. Every emotion you've ever felt was your brain trying to protect you, connect you, or prepare you. It doesn't always get it right, but it's always trying. You don't need to stop feeling them. You just need to know what they're actually saying. If you've enjoyed this video and want to see more, please comment, like, and subscribe. Let's keep growing together.